It's a fact of life. Water mains break. Studies have shown that what we do when repairing a water main, or more correctly, what we don't do, can have an impact on public health. People can become sick, and some people can die. Where a main can be repaired with the water still flowing under pressure, the risk is low. The real risk is with repairs that require isolation of valves and dewatering of the main. Why? Because in the process of repairing a main, disease-causing bacteria, viruses, or protozoa from bird or mammal feces have been allowed to enter the inside of the water main and contaminate the water. Those contaminants can come from contaminated pipes and fittings, contaminated backhoe and vac truck fittings, particularly where equipment is used for both sewer and water maintenance, contaminated boots, work pants and tools, particularly where work crews have responsibility for both water and sewer maintenance, boggy ground surrounding the pipes, nearby sewer mains, and trench water getting into the cut pipe. Remember, it's not how long it takes to get the water back on for the customers, but how long it takes to get safe drinking water back onto the customers. That is, water that will not make anyone who drinks it sick. So how can this be prevented?
As part of our procedure of cleaning pipes, we use 4% of chlorine, all our protective gear, glasses, gloves, coveralls.
Firstly, ensure all pipe sections are cleaned and disinfected and stored with sealed ends. And that all gear bolts are stored in such a way that it prevents any contamination. For example, in sealed plastic bags. Pressure wash and disinfect backhoe buckets and vac truck fittings. 1% hypochlorite is the easiest to use, but other products are acceptable as long as they are approved for use with drinking water. It may be easier to just use 4% sodium hypochlorite from the drum to avoid unnecessary handling. When repairing the main section in question, after checking for telecommunications cables or other services nearby, expose the pipe using either a backhoe with a clean, disinfected bucket or clean, disinfected vac truck hose. Vacuum excavation is becoming more common due to the risk of damaging fibre optic telecommunications and other cables. In some situations, some hand digging may be required. Ensure at least a single fist clearance under the break area. Make sure the trench goes well past the break at both ends and is wide enough to allow easy access for the work crews. Dig a sump at one end, well away from the work area to allow placement of a pump without it getting in the way of the work area. Lay out the necessary tools, fittings and pipe sections on a plastic sheet to keep them off the ground. AC bags make a good ground sheet for this purpose. Thoroughly spray the tools and fittings with a sodium hypochlorite solution. To prevent contamination from the workers themselves, disposable overalls and rubber boots dedicated for water work should be used. These can be white boots or normal black boots identified in some way. In hot weather, the overalls can be rolled down to the waist. Once everything is ready, the section of main can be isolated. Partially close the isolating valves, but ensure flow is maintained through both valves. If there's a hydrant valve in the section to be isolated, clean out and disinfect the hydrant point, place the hydrant in and open. Spray the area to be cut with disinfectant spray and wipe it down with a single-use wipe. Cut the pipe in the trench. Note the water continuing to flow from the pipe, thereby reducing the risk of contaminants entering the pipe. This is why the isolating valve wasn't completely closed off at the start of the repair process. Spray the cut ends and the areas where the gear bolts will go with disinfectant spray. Immediately start the pump in the sump and maintain minimum single fist clearance at all times. Measure the section to be replaced and mark the pipe where the cuts will be made. Cut the pipe section to size using a disinfected saw. A power saw or hand saw can be used, and in some cases, a complete length of pipe will be required. Indeed, for AC mains, best practice is to replace the broken section from collar to collar. Keep the section either on the ground sheet or up off the ground. Place the gear bolts and move the pipe section into the trench without touching the dirt, and adjust the gear bolts to support the section. Tighten the gear bolts. Once the repair is completed, wait to the middle of the pipe to prevent the pipe lifting. Leave the gear bolts exposed to check for leaks when the water is turned back on. Perhaps the most important part of the Safe Water water mains repair procedure is how the repaired section is put back into service. Thorough flushing of the section of main is essential. Just flushing to get the air out is not enough. The main needs to be flushed at a rate of 1 metre per second for 3 pipe volumes. That means the volume of water between the 2 isolating valves needs to be turned over 3 times at a very high flushing rate. Where the hydrant is in the section of main between the isolating valves, the repaired section must be flushed from both directions independently. If the hydrant is outside the isolated section of main, a hydrant will have to be opened past one of the isolating valves and then the isolating valves opened. The one nearest the hydrant first and then the one furthest away. We can't measure flow in metres per second, so it needs to be converted to something that can be measured in litres per second. And the bigger the pipe, the higher the flow necessary to get to 1 metre per second. Also, the longer the section of pipe, the longer the flushing time to achieve the required turnover of 3 pipe volumes. The easiest way to measure the flow is with a direct reading instantaneous flow hydrant. But many smaller councils and water utilities may not be able to afford one of these hydrants. In that case, the rule of thumb is to flush at the highest possible flow rate for a minimum of 20 minutes. For pipes greater than 250mm, more than one hydrant should be used. Finally, after finishing flushing, measure both the chlorine residual and turbidity upstream and downstream of the repaired area. If the values are not the same, something is wrong, so keep on flushing.
0.24, and that registers above our 0.2, which is safe for people to drink. So we can now turn that water off and everything is restored back to normal, and we can now pack up and leave the job.
For the majority of mains repairs, this is all that is necessary. However, there may be an occasional repair where more is required. The main is next to or close to a sewer main, the main is in boggy ground, the backhoe bucket was not cleaned and was last used on a sewer job, or during the repair, the water level in the trench rose and water entered the pipe. In each of these situations, there is an increased risk of contamination of water in the pipe with microorganisms that can cause illness in humans. In these situations, disinfection of the inside of the pipe will be required. Chlorine needs to be added and the chlorinated water held in the pipe to achieve a CT of 100. Liquid sodium hypochlorite or solid calcium hypochlorite systems can be used. In both of these systems, it is easiest to take water from a hydrant upstream of the isolation valve and add it back, along with the added chlorine, through another hydrant across the closed valve. Flush chlorinated water needs to be managed so that it does not have an adverse impact on the environment. There are also specialised portable dosing systems available. These items of equipment are typically used for disinfecting new mains, can be used for repaired mains. While it may seem troublesome to set up such systems, water utilities and councils need to be prepared for what to do if it all goes wrong. As with any emergency procedure, it should be planned and practiced. Remember, it's way too late when people in your town start to get sick, and it's traced back to a poor water mains repair. If you think serious contamination has occurred, a boil water notice must be put in place promptly for all properties downstream of the repair site. Following work processes like this, water utility staff often comment it will take too long or it will just cost too much.
We find the water safe procedure works really well, with a great uptake by the operators out in the field seeing the benefits of the safe water procedures. We've managed to reduce risk in water quality within our delivery services without having a significant impact on resources and time.
Our main focus with this is that safe drinking water doesn't make people sick. What we found is by implementing this procedure, there's hardly any impact on time or cost, but it reduces any risk to our customers, which is the most important thing to us.
Western Water and Goulburn Valley Water in Victoria have been evolving their procedure and process for a while now. Over this time, the network operators have been trained and adopted cultural change as part of this new process, and the Water Industry Operators Association supports the universal adoption of this procedure as an ideal way to manage risk to consumers.